This is Mr. Best. Welcome to Math Analysis. Our first section that we will be covering is section 1.1, Lines in the Plane. A lot of stuff we're going to be doing here. We're going to be looking at slopes, writing equations of lines, talking about the different forms of lines. We'll do a little bit of graphing as well, and then we'll look at slope and parallel and perpendicular. So kind of the first thing is, slope. Well, we know slope is the rate of change. Rise over run is kind of what you first learn. Realize once again that we're, in terms of slope, when you do the rise, it's the change of your y value. So when you're looking at that as a graph, what's that label? What does the y represent over the change of x, and what does the x represent? And that slope is that rate of change, distance over time, things like that. So kind of the first part, as you look here in terms of the different ways I have the slope written, the delta is the change, so that's the change of y over the change of x. And when we say change, we're talking about the difference. So you can see that we're subtracting. Anytime you want to find the distance between two numbers, you subtract them. So that's why we do the change of y over the change of x. The subscripts 2 and 1, those just represent which point you're choosing. It doesn't matter which one you put first, though. Some of the formulas that we need to be talking about in terms of linear equations are the standard form. Now, standard form for you guys, most of you remember, is ax plus by is equal to c, but we're going to use the general form, which is ax plus by plus c is equal to 0. When we do the general form of conics and things like that and all these other equations, we always set them equal to 0. So the general form that we're going to be using for equations is ax plus by plus c is equal to 0. Sorry about that. And really, what we know about this equation is we know that the ordered pairs represented by xy. Slope-intercept form, probably the most common. Y is equal to mx plus b, where we know m represents the slope of the line, the rate of change, and the b value is the y-intercept. The next one, point-slope form, if this is not something you're familiar with, it definitely needs to be something you're familiar with. Point-slope form is you have a point and you have a slope. So if you go back to your m value in terms of your slope in the formula, you have m is equal to, kind of do this off to the side here, you have m is equal to the change of y over the change of x. And I just used 1 this time. So m is equal to the change of y over the change of x. And this is really given 2 points and a slope. So point-slope form, what if we solve this for y? And we multiply both sides by x minus x sub 1, and that would give us, I'm going to rewrite the y on this side, y minus y sub 1 is equal to m times, because this one's going to cancel and it's going to move it over to the other side. And then what happens, I can shrink this up a little bit, what then happens is, now I can add that y to the other side, but we're not going to solve. This right here represents your point-slope form. And so if you've never seen this one before, or if you haven't used it much, it's definitely something we're going to be using this semester. I prefer it over slope-intercept when I'm trying to write an equation of a line in most cases. So a lot of times you're given a point and a slope, and you can just plug it in and solve for y. So there's your point-slope form. Comes directly from the slope formula. Your horizontal line, you can still write in slope-intercept form. It's y equals mx plus b, but a horizontal line has a slope of 0, so the equation of a horizontal line simplified would just be y equals b. And then of a vertical line, since you can't write the equation of a vertical line in slope-intercept form, the slope is undefined of a vertical line, the equation, when you write a vertical line, passes through the x-axis, and so we will say that x is equal to this constant of a. So those are really the different forms in terms of your equations that you definitely need to know. Point-slope form might be one that some of you are not familiar with that I want you to become more familiar with, and I'll show you in terms of using that today as well. So some of the general questions that can be asked, just kind of, once again, we're just getting started here, kind of checking your algebra, things like that. Write an equation of a line in standard form through 2 points. So what I would do right now is pause the video, give you a minute to kind of see if you can think through this yourself. Go back to your Algebra 1 days and see if you can write the equation of the line given 2 points. So the first thing is given 2 points you can find the slope. So we're going to do the change of y over the change of x. And I'm doing the first point minus the second point, but once again it doesn't matter. And so what we'll get on top, minus and negative is a plus, so that would be negative 3 over positive 8. So we now know the slope. Well, we know the slope in 2 points. So if we have the slope in 2 points, we can use point slope form. So really it's using the slope formula again, just written in this form, but instead of plugging in the x and y values, both of them, now we know the slope. So we're going to plug in a point, pick any point you want. We got the 3, negative 4, or the negative 5, negative 1, and the slope that we just found, which was negative 3/8. So those are the two things that we're going to plug in. So it'd be y minus negative 4, so that's plus 4, is equal to the slope times x minus 3. So in point slope form, it's not simplified, but that's what you have right there. And if we want to write this in slope intercept form, which we really want to go to standard form, but let's simplify this and get rid of the parentheses and stuff first, and then we'll go to standard form. So we have y plus 4 is equal to, and then we're just going to distribute. So that's negative 3/8 x, and then negative 3 times negative 3/8 times negative 3 over 1 would be positive 9/8. So that's me just using the distributive property. And then now we need to subtract the 4 to the other side so we can get it into slope intercept form. And so 9/8 minus 4, you can do that in your head if you want to. 1 1/8 minus 4, you can rewrite it with a common denominator. You can use your calculator. Whatever you want to do in terms of simplifying that is completely up to you. That would be minus 23/8. And so if you want to kind of see that, that's 9/8 minus, I'll just do the common denominator part, so that would be negative 32. And so that's where the negative 23 as an improper fraction comes from. So if I wanted you to write this in slope intercept form, we'd be done. But we want to go to standard form. So standard form, we want everything on one side. We don't want any fractions, anything like that. We want the x value to be positive. So we want to get rid of all of this. So we want to get rid of the denominator. So let's multiply by 8. So that definitely looks better already. And then we're going to add 3x to the other side, and we're going to add 23 to the other side. So everything on that side cancels, and what we're left with is 3x plus 8y plus 23 is equal to 0. So a very simple equation, general form, looks very nice. And that's it. So that's the equation of the line given those 2 points. Instead of using point slope right here, you could have used slope intercept form and found the b value and then kind of did it that way as well. But either way is fine. Okay, let's kind of move on to the next thing. Parallel lines are distinct lines that have the same slope. So, you know, the slope of the first equation is, I'm just going to say a over b. Then the slope of the second equation is also a over b when they are parallel. Perpendicular lines, if you think about perpendicular lines, they form that right angle. One's positive and one's negative, so we know that perpendicular lines are going to be opposite each other, but the other thing that they are, they're not just opposite, but they're opposite reciprocal. Okay, so if the first one is a over b, then the perpendicular slope is negative b over a. So once again, taking some of those Algebra 1 skills, giving you another example here, see if you can work through it and identify what the equation of the line is that passes through the point 2, negative 1 and is perpendicular to the line 2x minus 3 equals 5. Okay, so you have a point that it passes through, and we know it's perpendicular to this line. So once again, pause the video for a second, think about this. How can you go about solving this problem? Alright, the first thing is, if this is perpendicular, we need to find its slope. So how are we going to find the slope? Well, we're going to write it in slope-intercept form. So that'd be negative 3y equals negative 2x plus 5. Divide everything by negative 3, and we get y equals positive 2/3 x. And we don't really care about the last term here. Our only focus is on what is the slope. And so the slope is 2/3. So we know this slope is 2/3. So what is the slope perpendicular to that? Well, the slope perpendicular to that is the opposite reciprocal. So now what do we have? Well, now we have a point at 2, negative 1, and we have a slope of negative 3/2. So now you have a point and you have a slope. Can you write the equation of the line? And the answer, I mean, compared to what we just did, this one, you know, you got a point and a slope. You're only writing in slope-intercept form. You should be good to go. I'm going to use point slope first. So y minus negative 1, so that's plus 1, is equal to your slope, which is negative 3/2 x minus 2. Distribute. And then subtract the 1. So y is equal to negative 3/2 x plus 2. And it doesn't want it in any other form, so we're good to go. And so a lot of this stuff on the first section is really just kind of going back and remember some of those algebra skills in terms of lines and linear, and really just getting you guys to practice some of those things. These are things that we will use, you know, throughout the entire unit, and not really a lot of time that we're going to be spending on it. So if you have any questions on these things, please make sure you ask. Alright, the very last problem that we're going to do is going to be dealing with application problems. Something kind of real life that we could be talking about in terms of linear equations. The numbers on this one are pretty nice, but the idea behind it is really what I want to focus on. So during 2000, Nike's net sales were $9 billion, and in 2002, net sales were $10 billion. Write a linear equation representing the situation. Then use the equation to predict the net sales for 2007. So the biggest thing that I see on these types of problems is we try to jump into the problem too quickly. We don't go through and identify what it is that we're trying to do. It says write a linear equation. If we have a linear equation, or really any type of equation, you know, we're dealing with two variables, two unknowns. So when you go to set this one up, what are your two unknowns? You know, when you go to graph this, what is your independent and what is your dependent variable? And that's what you need to identify really before you ever get started. So on this one, you know, this ordered pair that we're going to have to set up, what does it represent? What is the input value? What is your x-axis down here? Well, you're dealing with two things. You're dealing with time, and you're dealing with money. So when you're dealing with time, that's going to be your independent variable. So we know time in years is going to be our x value, and then the cost or the profit of the sales is going to be the dependent variable. So that to me is very important. If you don't figure that out first, then the rest of it, maybe you get right, but you're definitely going to be confused as to what's going on. So now what do we have? Well, we have in 2000, the sales were $9 billion. Now, do I have to write all those zeros? No, as long as we understand that the sales are in billions of dollars. And then we also have in 2002, it's $10 billion. Now, we could use the years 2000 and 2002 because technically that's the year that it is, but we don't have to start at 2000. You know, if Nike was introduced in the year 2000 and that was its first year of business, you know, well that would, you know, that's time 0, okay, or time 1. So that's really, instead of using 2000 and 2002, let's make this easier on ourselves. Let's say at time 0, kind of that first year it's in business or whatever, that the sales are $9 billion. That's our initial value. That's what we started with. And then 2 years from now, it's at $10 billion. And so I think if we use those numbers, that'll be a little bit nicer when we go to write our equation and make our prediction. So given 2 points, can you write the equation of a line? Well, go back to question number 1. Given 2 points, can you write the equation of a line? So you should be able to do that. So I'm not going to use these two. I'm going to focus on the two smaller numbers here. And we're going to write the equation of a line. Well, the first thing is to find the slope. So we get a slope of 1/2. But don't think of the slope as just being 1/2. What does that mean? Well, y represents the sales and x represents the time. So what does that slope represent? Well, 1 billion in sales for every 2 years. Okay, so that's that rate of change. Don't just think of it as a number, decimal, or anything else. What does it represent? And so now we can write the equation. Once again, we could use point slope form or slope intercept form. If you actually notice on this one, because of the way we set it up, this represents the y-intercept. So we actually wouldn't have to go through this process because we have the y-intercept. We could just say y is equal to a slope of 1/2 and then x minus, whoops, I don't know why I put the parentheses in there, 1/2 x minus 9. So here's your equation in slope-intercept form if you use 0, 9, and 2, 10. If you choose to use the 2000, 2002, that equation will look a little different. But when you go to predict, it'll be exactly the same. Just make sure you use the actual year 2000, whatever, 7 on that one. But we want to use this equation to predict the sales. Well, we want to predict the sales in 2007. So our x value is not 2007 because of the way we set it up. Our x value is 7 because we went from 2000 to 2002 to 2007. That's a span of 7 years. So then we just plug it in. Y is equal to 1/2 times 7 minus 9. Why did I put minus 9? Sorry, it should be plus 9. And we get y is equal to 3.5 and 9, so that's 12.5. And then at the very last, make sure you guys answer the question. What is being asked here? Don't just tell me 12.5. Don't just write the equation of the line. I'm looking for very specifics. I'm looking for detailed information. I'm looking for understanding and not just being good at math anymore. I want you guys to be able to write this stuff down and make sense of it. So when it says use the equation to predict the net sales for 2007, then let's answer the question. In 2007, not right. Try to type this. So in the year 2007, we predict the net sales will be 12.5, but not just 12.5, $12.5 billion. Or I could have put the dollar sign in front of the 12.5 and just put 12.5 billion. Either way is fine. So in 2007, we predict the net sales will be $12.5 billion. So I'm looking for an answer in terms of that. What is it specifically that we're talking about? Make sure you have the labels and stuff on there. So that's really the first lesson. Going through a lot of, like I said, linear equation stuff. Hopefully a lot of this stuff is review and you're able to go through it, but don't assume that you remember how to do all this stuff, especially in this class. It'll take what we did in Algebra 1, Algebra 2, and really stretch what you have done in your previous classes. Even though the material looks the same, I'll be asking you some different types of questions and things like that. So when you do the homework, make sure you complete it all, look through, especially look at those end ones, 82, 83, 84, 85, 95, 96, 98. Those are going to be some more of your application type problems. The odds are in the back of the book. You can check those. Also, you can check them in my classroom. The VC, that's a vocab check. So the 1 through 4 that you're looking at, that's going to be a vocabulary check that you have to do, and you'll see that in the textbook. Thank you.